Okay, I'm going to give everybody 1 minute to settle down and we can get started. In that 1 minute, can I get help with note taking, please? Besides you, Peter. I'm hoping somebody can use HedgeDoc. Thank you, Peter. Wow, we have 2 Peters. Well, you're PIETR. You will be on HedgeDoc. He's doing it in a separate document. So thank you. Okay, so I've opened up the chat and I've said hello there, but I haven't gotten any responses. For those who are remote, can you hear us? Thanks, Akira. Thanks, Pingling. Okay, let's go ahead and get started. Good afternoon, everyone. This is the Trusted Execution Environment and Provisioning Working Group. So if you're not expecting to hear about TEEP, you may be in the wrong room. Welcome, everyone. Why is this not advancing? There we go. Okay. So hopefully by now, everybody's familiar with the note well. This is an official IETF meeting. So the IETF rules apply. We lost somebody. Thanks. All right. I don't know why the PowerPoint is not sharing well. So for those who are here in person, if you're not logged in, let me just pass around. So the IETF is trying to make sure we capture attendance properly. So for those who are here in person, and if you're not logged into the Meet Echo, we're passing around the QR code scanner. For those who are remote, make sure both your audio and your video are turned off so that we can have, and you can have the best experience. Strongly recommended that you use a headset. When we have the discussion, then you are free to unmute and put your video on, but when you're not speaking, please turn that off. All right, so reminder, code of conduct, keep the discussions professional and respectful. And I will thank both Peters for helping take notes. I don't know why we have the jabber. We don't do that as much. So Peter Kesselman, are you going to use the HedgeDoc? Awesome. Thank you. Yeah, the HedgeDoc is a live document. So if you want to keep track. Thank you, Peter Yee. He takes awesome notes. He will not be using HedgeDoc, but for those who want to keep track of the notes that Peter Kesselman is taking, you can look at the HedgeDoc. All right, so with that, let's do the agenda bash. So we have a full agenda. We do have time at the end for discussion, but let's spend the next few minutes or seconds agenda bashing. So before we go through this, I want to congratulate the authors of the architecture document because it's finally now an RFC 9397. Done. Check. So thank you, Dave, Ming, Dave Wheeler's not here, but that was a long and good piece of work there. And Akira too, because he contributed a lot of feedback to it. Okay, so with that, I think we're getting close with the protocol shepherding feedback. And then Akira is going to give us an update on the implementation updates. And then we have Peng Ling with the adopted draft on the confidential computing use case. And then there's a couple of new drafts that are going to get presented using TEE's distributed provisioning. And then we've got Juan, is that how you pronounce your name? Joanne. Okay. Yeah, when I saw, because I'm Latin speaking, so I was like, Juan. So Juan. Okay. We'll talk about her draft on confidential virtual machine provisioning in a cloud environment. So any updates, changes, modifications to agenda, going once, going twice? All right. We can move forward. So Dave, you want to come up? And all right.
All right. Draft 15. Dave Thaler, next slide. You don't have to click it. So. All right. This is what's happened since last IETF, right? Last IETF, we were discussing draft 12. And so since last IETF meeting, since March, we've had 3 versions of the internet draft posted. And we've had a working group last call that has gone through. And we've had the document shepherd review and write up. And then we've had a hackathon. So a lot of stuff has happened since last time. Very few things to discuss compared to previous meetings, but there is things to discuss. And so I'm going to cover those. My goal is that after this meeting, meaning after like this physical meeting that we're in this room right now and before the end of the week, to post draft 16. And the document shepherd can then do whatever the next task is. And we can ask at the end whether there's another working group last call or document shepherd review or whatever. And you can decide that. Okay. And so the goal is to get to the ISG as soon as possible so that we can also be done with this one. Okay, next.
Yay.
That would be wonderful. So often we say, what set of normative references? What are we blocked on? And so here's the list out of the things that are not already RFCs, like the TEEP architecture is already an RFC. So it depends on one RATS document that's already in the IESG. So that one's already ahead of this one, not a problem. And it depends on 4 suit documents, right? The first one is already in the IESG. I'm getting a little bit of feedback, interesting. The second one has already done a working group last call and is in process of being updated. We talked about all of these yesterday in the suit meeting. And the last 2 is a result of the suit meeting. We decided that they were either already ready for last call or would be ready for last call within the next couple of weeks. Okay. And so that means that I am not particularly worried. Some of those might, if this one goes to the ISG, it might still be waiting for either MTI or report. But the goal for both of those is to get them done before next IETF. And so that means if we do all of our jobs and as chairs getting the other suit authors to do things, then in theory, we could be done by November. So we will see.
We will see.
November, yeah, because we're still got to go through IETF last call and everything. So you never know what's going to happen after that. So
right. It's a question of whether we want to wait and go in parallel with the other ones, or we can just have it go through and then have it just sit in the queue until the other ones go through.
Yeah, I don't think that there's any reason to wait, given that there's, and I see Ken nodding as well, that there's probably nothing that we would want to change in this document as a result of feedback on one of the dependencies, and that's because there's a good division of labor there.
Yeah.
It's very unlikely. And so the point is, I don't see that there's any reason to like remove text because we'd be sitting there for a long period of time.
No,
like
I'm not suggesting we remove text. And I mean, it's 6 of one, half dozen of the other, whether we wait, there's no.
I don't have a strong opinion, but I don't see any reason to wait, but that's up to the chairs and the shepherds. So. All right.
I'm fine moving it forward once we're ready.
Next slide. Okay, so I'm going to actually talk about the changes since I was standing in front of the room in March. So let's go ahead. All right. So because anything that we talked about in March has just been done to what we talked about in March. Okay, so anything that we presented in March, we said, yep, that's done. So I'm not going to repeat any of the issues we talked about in March. Everything there is new because we had a working group last call after last IETF, and so there's a couple issues that were raised in the working group last call and that were then addressed. And so I'm going to talk about those first. So the first one is Akira correctly pointed out that the TEEP architecture talked about attestation in both directions, right? So both the TAM and the TEEP agent can both attest to each other. However, the protocol document only previously had it in there for one way, right? That the TAM could tell whether the TEEP agent was trustworthy, right? So that the TEEP agent would send its, attestation stuff off to the TAM, and the TAM would look at it and say, yep, this is one of my valid devices to manage, or it's not. But there's nothing in there about the other direction, right? The TEEP device, the TEEP agent couldn't say, I'm only going to accept it from a non-compromised TAM, right? The architecture document had that scenario in it, but the protocol was like missing the fields for that, okay? And so as a result of that, then we decided it was not that hard to actually add that in there, given that we had defined the various fields and you just giving it in, sticking the same fields and a message that goes in the other direction. And then you can repeat a lot of the same stuff, right? Without having to respecify it. Okay. And so the way that works is there's a message that goes from the agent to the TAM, okay? And so we put the stuff in there so that you can say, sorry, I need attestation evidence if you didn't send me any, or your attestation payload, whether it's background check or passport model. And if you're using something like a freshness check using a nonce, that's where you'd stick the nonce, right? That the other guy's to stick in as evidence, right? So as an example, you'd send a query request and then some error comes back that says, hey, I need you to attest, please. And by the way, here's your nonce, okay? And then the TAM can then send another message to the agent with a new query request that actually contains its attestation payload, which incorporates the result of using that nonce to generate it. Okay. And so there's no new messages, although in the worst case, there's an extra round trip there, right? Because you got to send one message, get the message back that says, sorry, you didn't send me with the right nonce. Here's your right nonce. And then you do it again. Okay. So there you go. So that's the mechanism that we put in. Next slide. Okay, unless there's any questions about that. There's pure editorial stuff, which has already been addressed and not worth discussing. And then there was 2 issues that were filed at the hackathon over the last preceding weekend here. All right, no questions? All right, we'll go to the hackathon ones. Okay, so here's the first one. So we have the notion of this error return for a query response, right? And so the query response comes into the TAM, and the TAM looks at the query response and it doesn't parse correctly or it doesn't attest or whatever it is. And so what does it do, right? In older versions of the draft, the TAM only had 1 recourse, well, 2 recourses. It could drop the packet, or it could try to update the software on the agent to say, here, so you should be doing the right thing. Let me fix your software for you, okay? So the problem with that is that there are various scenarios where there's multiple TAMs for the same device. So for example, you got one TAM that can update your firmware and a different TAM that's responsible for some little app. Okay, and the TAM for the app might have a failure. And of course, it can't update the firmware. That's the other TAM's job. It doesn't have permissions to do that. That's a different trust domain in the suit sense. Okay, and so what does that TAM do? Because you could drop the packet, but that doesn't really help whoever owns the TEEP agent. Now he'd have to go and look at the logs for the TAM, right? And so instead we said it sure would be nice if there's a way to get that error information back so that the TEEP agent can log it or flag it to a user or whatever it's appropriate. Okay. And so we said, okay, well, let's put some information in there because again, we've already got that in one message in one direction, okay, that the TEEP agent can report to the TAM's mirror information, but there was no fields to go in the other direction. So I said, gee, given that we've specified it once, can't we copy the same fields into the other message in the other direction? So great, we can do that. So that's where this comes in. So we added into the update message, error code and error message, right, which has already existed in the query response. We added the same 2 fields there, okay? So you can do it the same way, just in a different message that goes in the opposite direction. So you can update them and update 0 components in the thing. It says, here's an update. I could update your firmware, or I could update 0 components and just use the same message and say, here's the error message, okay? It just reuses the same message, okay? Next slide. Okay. So here's what we did. So draft 12 actually updated the syntax, and it had those fields in there, but it didn't actually update any of the text about the behavior of what a TAM does. So it didn't say you should actually use them for anything or how you use them, right? So the fields were in the CDDL, but that's all, right? And it also contained this problematic text about other errors in the query response. It still said the TAM drops the message, and it may do implementation-specific stuff too. And so it's kind of ambiguous to say, well, okay, just drop the message. Did it mean that you're not allowed to send an update message? Or does it mean that sending an update message with error stuff is actually implementation-specific detail? So that's probably not the right thing. Okay. So we discussed at the hackathon among all the implementers that were there, both locally and remotely. Right? Akira participated in the hackathon remotely. And so, you know, Hannes and Sobe-san and I and Akira all talked about this. And we said, yeah, let's do the same thing here. And so we generated a pull request during the hackathon, and then we all reviewed it, and now we're reviewing it with the rest of the working group. You think of this as the design teams reporting back out as to what we all talked about implementing. So next slide, you'll see what we did.
Did you actually implement it during the hackathon?
I did. I don't think they did, but I did.
Yeah,
so
I
we
was
had one
gonna say-
implementation during the hackathon. Because I filed this when trying to do the implementation in the first
No
place.
interoperability yet.
No interoperability yet, yeah.
Okay.
Although the implementers, I think you looked at your implementation and said it would work if you did it, right? Okay. So that's good enough proxy for me to say that the pull request was good to present to you guys. So, all right, so here's the changes in the actual text. Okay. So the first one is in the TAM behavior section. It says, you know, this is what used to say the bold text is added, right? This stuff that's not bold was there before, right? If these requirements are not met, right? So if something doesn't parse right, it doesn't attest right or whatever, the TAM drops the message. Okay, and I add and sends an update message containing an appropriate error code and error message. Okay, now let's just actually use it. Okay, so the main point here is because we said, should it be a may, a should, a must? And so this language right here implies it's a must. Okay, if you're going to drop it, okay, then you send them an error. Okay, and we made sure that this is only in the query response processing. You would never do this in an error processing the error message, right? You don't want an infinite series of errors, right? This is not an error message, so it's safe to always send an error there, okay? Because you'll never get an infinite loop. You never send an error in response to an error, but you can send it in response to a normal message. That's fine, okay? So we did talk about that. So that's one of the two text changes is saying it's a must. If you're going to drop the query response, you send an error message. You send an error message by putting it in an update message with no components, right? Because that's where the fields are. If you have a components to update, you can do that too, right? If you are the TAM for the firmware, you can say, here's the error, and by the way, here's your new firmware, right? That fixes that bug. Or you know, upgrades to the latest version that would be in policy, whatever it is. Okay. All right, the other place in the document that had to change was where it said, you know, the crossed out lines replacement. In this case, this is talking about attestation failure. It says the TAM used to say, TAM can attempt to use TEEP to update any trusted components. Well, of course, that is false if you're like an app TAM that doesn't have access to that trust domain, right? That can is false, right? And so we had to update it to say, okay, it might attempt to do that if the TAM doesn't have permission to update those components. And this can happen if different TAMs manage different components in the device. The TAM instead responds with an update message containing an appropriate error message and error code set to attestation required, right? So that's the same error code that we're using in the other direction, right? We're just saying a lot of these error codes are now bidirectional error codes. It could happen on either side, because things like attestation and message parsing and certificate expiration, they could happen on either side. Okay, so we're just reusing the same error code space, same definitions. And that takes me to the next slide, which is we need editorial updates to the various definitions of the error codes. So a lot of the error codes were phrased as implying a particular direction that now needed more agnostic wording. So here's a couple of examples. Okay. One error code was defined as the TEEP agent doesn't support the TEEP protocol version in the request message. Okay. It says, okay, there's a version mismatch. He sent me a version 2 and I'm only version 1 or vice versa or something like that. Okay. But that could happen in either direction now, right? If the parsing of query response said, that's not the right message. I sent you a query request version 1. You sent me a query response version 2. You're just wrong there, right? And so what error message you use? So we said the TEEP Agent changes to implementation as being the term that the document is using right now for agnostic between TAM and TEEP agent. It says TEEP implementation and doesn't support the TEEP protocol version in the received message. So now it's independent of whether we're talking about a query request or a query response. It's whichever one you received. Okay. So this is just one example because those words, it's like search and replace throughout the error section, right? Because there's a bunch of them. And then another example, this one was previously a TAM side one. It says a TAM receiving this error, what it might do. Okay. And this says a TEEP implementation receiving this error, because now the error could come to a TEEP agent. Okay. A TEEP implementation receiving this error might retry the request and retry the message it sent to the sender of the error at some later point, right? So it had to have some language to be agnostic as is it resending a query request or resending a query response or whatever. Just having agnostic wording. So all of these are pure editorial. There's no behavioral changes here. It's just saying a lot of these are useful. What I didn't do it for, next slide, and you can double check my work. This is the list of all the errors defined in the message in the document. And I had to decide which ones could actually be bidirectional versus which ones were actually directional specific. This is my answer. All the ones in the top category are ones that could apply in parsing a query response. All the ones in the bottom can never apply to parsing a query response, and that's because the ones on the first two on the bottom have to do with how capability negotiation works. Capability negotiation always works, one-sided, where one side sends, here's the set of supported ones, the other one makes a choice, okay? And since that one is direction-full, the capability negotiation, both of those are capability negotiation errors, they can only ever occur in one direction. And then the last one is because TAMs don't process manifests, right? Manifests always go to the agent, right? Okay, so I didn't have to make any wording changes to those three. All the top ones, the wording changes matched what was on the previous slide, just in the appropriate instantiation. Okay. Does that kind of make sense to people? Okay. Well, the implementers are nodding, but they were in part of the discussion before, so okay. All right. And I only got one other issue to talk about. So that was the major thing that we talked about, and we're working on implementing and so on. So here's the other one. And so this one goes down inside the EAT profile. So now we're down in the EAT profile that's defined by the TEEP protocol spec right now. And it has a COSE key fingerprint. And so the TEEP profile, or the EAT profile section currently says, here's the existing text, get identification, key ID is used, or COSE key ID is used, where the key ID is the hash of a public key. And it explains what that public key is, right? This notion of it's a hash of a public key, well, what type of hash is it? Well, see those sections for discussion on the choice of hash algorithm. You go to those sections, and they say it's SHA-256, right? So it's a SHA-256 hash of the public key. That's what you get by looking at the document right now. Okay. Well, it turns out that there's a document here that's on the COSE agenda for the week, and I think did it already happen? Okay, the COSE. And so maybe if you want to get up to the mic and just tell us how that discussion went. But this one is actually the details of how to compute that hash written in a very short document. It's an internet draft, but it's not very long. It's a couple pages, right? And so our choices are, and so I want to hear how it went in that document if somebody wants to get up to the mic who was there. But our options would, since this one has not been addressed yet, right? That's why draft 16 and stuff hasn't come out, right? We can either normatively reference this new draft, and that adds it to that list of stuff before, and this was proposed for adoption in the COSE working group, not for working group last call, but for adoption, okay? And so that one would slow it down. Another thing that we could do, we could find a way to informatively reference it, or we could choose to not reference it. And this is what I would like the working group to tell me which one of those three approaches we should do. So I'm curious to know how it went in the COSE working group.
Hi, this is Kohei. I submit this issue. So my intended was not to block the making the standardization process. So, but so the current descriptions is so not so much for kindness for implementers. So maybe so I think so the probably so the TEEP protocol is so used by the COSE implementations. So maybe so yeah, our IDs are useful for implementers, and so to make interoperabilities over agents and term implementations and so on. So in summary, so yeah, my hope is B. So informative references are good. Yeah, maybe so. Yeah, normative reference is also useful, but so this is so not critical part of using the TEEP protocol. Yeah.
And then how was the reception in the COSE working group? Will it be adopted, or what was the?
Yeah, there was hi, this is Hannes. There was a call for adoption, which was started early July, and there was a lot of positive feedback, and the call concluded already. So I sent a message so that during the meeting, the chairs noticed that they should have already sort of summarized or conclude the call. I've sent them a message, a reminder. So it should be like anytime they have the chance to do that. So there was no negative response, only positive feedback. So in that sense, and it's in scope of the group, so it kind of feels like a no-brainer. We had no open issues when we presented the document. Brenton then raised one open issue, where he wanted to include the thumbprint of the symmetric key, which we would have to add. But then I think, as you said, it's a very simple document. It's just the mechanics of getting this done. And so, yeah, so I expect that to advance very quickly.
Okay, so it sounds like it hasn't been adopted yet, but that's more procedural. Somebody has to click the right buttons, right? And it's short enough that it sounds like it shouldn't be that long in the working group, given the shortness of the document. So I guess the real question is, because I'm kind of hoping the answer is B out of these options. That's the one I like the best too. But I guess the question is from somebody else who's actually implemented this part of the spec here. Do you think that the text that I'm citing here, plus the text in those two sections there that basically says the hash algorithm is SHA-256, do you think that that is sufficient to unblock an implementer? In which case it's informative. It just gives you more details about it, but you could still do it with only reading this text right here. Or do you think that you'd need stuff that's in the COSE key thumbprint in order to correctly do it in an interoperable way, right? Do you think two people would have different implementations would not interop without that draft?
They will have interoperability problems at the point when they try to come up with the same values because they will, if they pick them in the wrong order, wrong set of elements, it will cause some problems. However, having said that, I think I'm fairly positive that this document actually progresses faster than the protocol document. So I don't believe ultimately it will be an issue. And if you go for B right now, and then shortly before the document reaches the RC editor and goes through all these review processes, then update it as the need arises.
If you think that you could have two implementations that don't interop just using the text that's in the document right now, then I think it would have to be A.
Okay.
Yeah.
Okay.
I mean,
Yeah.
based on
It's
what you
like,
said, Hannes, for interoperability, it has to be A.
Yeah, because that's why we also wrote the document.
Right.
Because we were trying it in a different context, so it's not the only context where this issue surfaced.
I mean, and really, for the process, whether it's normative or informative, I think we still would want to parallel the process.
Yeah,
And so
yeah,
we can still put, what I'm saying is it shouldn't stop us progressing it, given that you're already in the process of adopting the SOBE draft.
But this one, we haven't written the pull request yet because you'd write it differently depending on whether we go with A and B, right? And so
Right.
If we go with A, we'd add it in as a normative reference and use must language.
Right. But I would agree, given that the draft is describing with clarity how to generate the hash. That's an interoperability.
It's like,
so it has to be
3 pages plus all the boilerplate stuff, right? It's short.
Yeah. So
Okay.
I think it has to be A.
Okay. Any objections to doing A, which we will add a must in there with the normative reference? No objections? Okay. That was what we needed to know, because now we can actually author draft 16 and post it. Okay. Did I have any other slides, or was
You
that
did.
the last one? Okay. Yeah. So there you go. Are there any other issues that we know of, given that we've already gone through one working group last call? Anything else that somebody wanted to talk about? Because I think I've collected everything here. It's either already been fixed because we talked about it last IETF, it was trivial and editorial and already fixed, or it's on the list we just talked about. And so unless there's anything else, then I will get another draft posted within the next, say, 2 days or whatever. And now that you know the content of what has changed since working group last call, I will let the chairs decide whether you need a 1-week working group last call or just a Doc Shepard
Well,
review or
I'll
whatever.
confer with
Didu.
Didu. But given that it's mainly been the implementers, so Akira, you know, I could ask you too, because he was the one that did some of the issues. If he's comfortable with the changes, that's number one. Number two, to the implementers, do you feel confident that what's written in the draft is sufficient now? And the only reason why I'm asking is we've been maturing the draft, and in every hackathon, we've come up with little things. They've been getting smaller, right? But this is where I'm trying to gauge.
I think all known implementers are here virtually or physically, between Akira, Hannes, Ken, Sobe-san, and Ming. That's the set of implementers of all the implementations that we know of at any part of the spec.
And Akita just posted no objections. He's comfortable with. I'm presuming Akita with both the resolutions and implementation maturity.
Yeah, I'm Ken Takayama, other implementer, and there is a work in progress pull request on the TEEP protocol document, which is updating the personalization data suit manifest. So which uses now I'm testing. The manifest is I think it's correct, but I have to validate with other implementation like I'm asking COSE working group member to validate the encrypted payload. So then after that, I can I can be confident with the document. Yeah.
Because we have lots of different tools and stuff that people have been running to make sure that the examples that have hex and stuff are all correct and they get out of sync and then they get updated and stuff. And so Akira and Ken and folks have been pretty diligent at catching all of those as changes are made.
So to the point of what you just mentioned, it seems like that dependency and the issues may fall more on the suit side than on the TEEP side.
Yeah.
That's what I'm trying to gauge, right?
Yeah. So suit encrypted payload in suit manifest document. Yeah.
Right.
So
I think we have one example suit manifest. It's like a trivial one, I think, in the TEEP protocol appendix or something like that.
Yeah, I remember.
And I think that's the only case that we have like diagnostic notation for a suit thing, I think.
Okay. So I will speak. Go ahead.
Oh, Akira.
Oh, Akira, you're in the queue. Go ahead. Why am I not seeing the queue? Oh, that's why. You are on mute, Akira?
Oh, sorry. Yeah.
There you go.
Yeah. I like the word keepers. So anyway, what Ken was talking right now was it depends on the it's the implementation of the in TCOSE and suit parsing is not finished making it compatible all the way. So it's not really the TEEP protocol draft. So it's about the dependency of the library which using in our implementation.
Right. Understood. Understood. Okay.
Okay. All right. I think that's everything.
It's a good thing we have slop because you're 8 minutes over. But that's good.
But I think we on the implementation side that Ken also mentioned and Akira, I think there we are extremely close. We just had the discussion in the suit working group on defining some last things, which actually then make it possible to update the examples, so we have them streamlined throughout.
How long? So the question is to both the authors of the draft and the implementers. How how long before you can get the new draft? And how long can the implementers? 2 days. Sounds like the implementers may need more days to validate.
Yeah.
Correct.
Right.
We might need to, or we could do a call in August just to sync up, just to make sure, because we need to, different libraries are impacted. So we need to synchronize things, and we'd have to talk to Lawrence on the TCOSI library, because I've been working with him on that. And then rippling that into sort of the
So do you want us
suit
to
library.
host a virtual, or do you just want to do your own independent in August?
It's up to you. We can.
Since half the issue is about the relationship between suit drafts and TEEP drafts implementation, and suit is looking at having a virtual interim in mid-September, I'm wondering if we could just combine it with that and say, we don't have to have a separate TEEP interim. We just use the suit
The
interim
suit
for
to bring
discussion.
it up there. Okay. So that pushes it to the September. Okay.
Mid-September. Second, third week of September. Date to be chosen.
This is Dave Waltermeyer. I just wanted to jump in. I'm not in the queue, but we can coordinate on that and set
Okay.
something up.
You agree with that?
Yeah, it makes sense.
I got 2/3 of the chairs in suits.
Okay. Well, this is all to gauge the maturity of the draft, so I can sync up with Didu. I mean, given that the authors and the implementers have been aligning and on the content, I don't know that we would necessarily need another working group last call. But I want to double check with Didu as well, because he's the one that did the Shepherd write-up. Okay. Well, we're a little over, but that's okay. Next up, we have Akita. Let me. All right, Akita, you're on.
So, yeah. Yes, I'm just going to talk about the updates on the implementation and the stuff I did at the hackathon. Next page, please. Yes, after the IETF 1016 at the Tokyo, and that was January, February, March. Yeah. Yeah, I added a wiki page. And the reason of adding the wiki page is in the next slide, please. Yes. So many people who was attending at the TEEP working group session who were not the author. I'm not trying to be humiliating any author or something. That the people who was new to TEEP wanted to understand and more deeply in the TEEP because it looked interesting for them. So I thought I should make some introduction slide. So my real initial intention was to post the introduction of the TEEP, explaining about how it works, what's the use cases, and which internet draft and which RC to look for to understand the TEEP protocol. So it's for something who is new to TEEP but wanted to understand why it's important. And so, but at the same time, I thought it will be a good place to upload implementation. So I added the open source implementation with the links to the documentation with the PDF and HTML TAR file and the GitHub repo. And yeah, could be a little bit Japanese way, but source code tarball too, which used to be common in Slackware age in Linux, but yeah, it's still used in Japan. So, and next page, please. So I'm going to talk about the implementation I uploaded on the wiki. It was released at the end of April. And it consists with two components, TRF and TEEP device. Its detail will be explained in next pages. and what's TRF and what's TEEP device. But the first I'm going to explain about what is TEEP device. TEEP device is implementing the feature of TEEP agent in the TEEP architecture and TEEP protocol draft. In TEEP architecture, there's 3 main components: is TEEP agent, TEEP broker, TAM, and there's one more. It's a verifier, but yes, it's TEEP device is implementing about what's the TEEP agent do. Yes, and TRF providing API and SDK environment for the TEEP device to run on all different CPU, Intel, ARM, and RISC-V. And the implementation uses Isobesan's TAM proto as a TAM. And next slide, please. Yes, so this is more easier to understand the relationship. So TRF hides the difference of the SGX and OPT and Keystone because they all have a different API. However, the intention of and objective of the SGX and OPT and Keystone pretty much similar. So it has similar function with a different name and with different parameter. So it's adding the wrapper on all 3 implementation, which will make it easier to implement TEEP device, which has a TEEP agent feature with one source code. Yes, and next page, please. So, and also when I implementing this implementation, yes, software supply chain is getting important as there's other working group is skip, how to pronounce skit, and also historically it was really important to how to update each component with if the one of the software component is found with security bugs. So I did a little bit of take care of on this implementation. So it has all the copyright notice, license statement, and SPDX identifier. So which license this component is using without reading the license statement, just parsing the one line as a SPDX ID, and which is easy to understand what's this component what is the license are. And also this was in the providing Docker image, providing makefile, build instruction, providing CI script and stuff. This was primarily for our increasing productivity in our in the development side. But it's good to provide at the same time for the as a software component. So as to make it easier as a software component as a BOM or component parts or something in hardware engineering side. And next page, please. Yes, and this is nice README documentation. Yes, it's always having a good documentation is nice, but it's always a burden to synchronize with the implementation and sync up. So if every time you changes the source code, it's a headache to synchronize with the documentation. So I use the Doxygen, so it will scan through the implementation from the source code and generates the README in the PDF format and like this in the slide is HTML format. And HTML format is it's more engineer and developer friendly. Next page, please. Yes, and this is the hackathon. Yes. Originally, I posted HTML version of the documentation as a tarball on the wiki page, but Dave, yeah, gave me an instruction for hosting with the HTML and rendering, HTML rendering place. So it was my first time to use GitHub IO, and the documentation itself was only written for Ubuntu 20.04 instruction, and some of them was failing to build on 22.04. So I add the build instruction for 22.04. And also the third thing was the more critical one. When the source code was released on the public, it had many pointing URL in the local repository, which was before it was becoming a public. So I fixed all the URL pointing with existing public repository. And also I had a report from some people having a build error. So yes, and then I pushed the changes to the README, and yes. And next page, please. Yes, the next step. So TEEP heavily relies on suit and rats. So there was a discussion right now at Dave's talk about Ken's implementing the example, how to yes, add the example in the TEEP draft. But yes, even in the implementation side, it's my implementation and Dave implementation, Ken's implementation, and Isabe's implementation. We in the future it will be nice to have a TEEP and suit and rats implementation all working on the TEEP implementation, because they all interact each other, because rats provides verifier, and then which verifier which we should use for our implementation. And right now everybody using their own suit manifest parser. It's probably it's okay, but it might be good to have one implementation using all people the same, so we could have more easier to bug fixing. And yes.
You have
And
Kohei on the queue. Akira, I don't know if you want to
yes, please.
take a question or go ahead.
Yeah.
Hi, this is Kohei. I want to report two news about hackathons. So one news is the N verifier. So that is can you hear me?
Yes.
Okay. So
Yes.
Yes,
one news is N verifier. That's N means naive. So is now open in a GitHub. So that is aim to the translate from evidence to the attestation results. Yeah. So that is my colleague finished his work. So now you can obtain the codes. And the second news is so in this hackathon, my efforts. Yeah. So in this hackathon, so my implementation is updated to the synchronized latest draft. So mainly update is so to supporting the terms attestations. So to generate terms evidence to and sending to the agents. So mainly so from my impressions. So the all is good working. So and so my implemented from my experience. So the latest draft is a good status. So maybe so, but so so yeah, so that is so limited cases. So I already so tested. So for example, so the in the fail of the attestations and so on. So I still couldn't test it. So maybe so I want to keep the continue to the implementations of evaluations. So additionally, so to say honestly, so in this hackathon, so we cannot work with Akira and so on. So finally, so yeah, you mentioned so integration test or interoperability evaluation is necessary for ensuring that our draft or our specification is good works. So yeah, so yeah, my concern is so when to the milestones. So yeah, so in the first item in this meeting, so maybe so we should hurry to the testing. So in the September. So, but so in my imagine, so the template have the many issues to support our all functions or all test cases. So yeah, so I want to consult with how to so testing the and so how to the assurance or prove the our specification is a good status. Yeah.
Yes.
So it sounded like we need more time to test.
Yeah, TEEP architecture, TEEP protocol, it's a pretty heavy software stack required. So let's coordinate. Let's work together. The draft is
Yeah, I
fine.
mean,
Just
I'm not hearing changes to the draft. I'm just
Yeah.
hearing maturity. Peter, you had a
Yes.
comment? Oh, dang, he's our note taker, so please. So Akita, you're at time. Oh, Dave,
Yes.
you were on the queue. Can you make it quick?
Yeah, I was just going to ask, is it possible to maybe shim some of the implementation so that we could maybe cobble together?
Well, that's
Some
what
kind of
Akita is
solution?
suggesting, right?
Yeah.
So he's got stuff on a wiki and on a GitHub available, but it's his code. And what he's saying in this slide is it would be good if we integrated everybody's
Yeah.
implementation.
I'd be happy to help with that at the next hackathon, or
Yes.
maybe in the interim.
Akita, you've got help.
Yes, thank you.
But Kobe-san is saying we need more testing and maturity. So,
Yeah. Thank you.
all right.
But so overall, so the document is good for us. So so the making a larger for the coverages of the all use cases. So I don't assess so how to important so the covering the all test cases and so the qualities. Yeah, but so yeah. Okay, yeah, that's all I want to say. Yeah.
No, this is great progress, guys.
Yeah.
I mean, the fact that we have multiple. Yeah.
And yeah,
All
thank
right.
you. My talk is finished. Yes.
Thank you, Akita. If you can repost, because it looks like we have new members. AJ AJ Stein on the chat is thanking you for this contribution because he's new. So if you can repost the wiki pointer on the mail list, I think that will
Okay.
continue to help. Right. That would
Yes.
be great.
Thank you.
Thank you. Awesome. All right. So next up we have Peng Ling.
Hi.
Hello.
Hello. Can you hear me?
Yes, we can hear you fine.
Okay. So this is an update of the TEEP use case for computational computing in network. The next slide, please. Yeah, this is some updates that I want to share. And the first one is the packaging model of the different applications. And in this version of the draft, we simplify the packaging model to 4 types, which I think includes all the possibilities of all the packaging. The first one is that we package the UAT and PD as one package. This is case 1. And in case 2, we think that the UA and TA are a package, and the personalization data is an independent package. And in the case 3, where trust application and the personalization data is one package, and the untrust application there could with it or without it. In the case 4, the trust application personalization data is an independent package, and the untrust application there could have or have no untrust application. I think that doesn't matter about the process of how you provision the packages in the TE environment. So next slide, please. This is update 2, and it's about the use case figures. And in this version, we use the confidential process and confidential container and confidential VM to replace the old version of the process, container, and the VM. And second, we use the parentheses in the load sequence to represent the package model. For example, in this figure, we can see there's a confidential process of this context. So next slide, please. Yeah, here's introduction improvement. So there's a comment that several months ago says that the introduction can be improved by describing early on what the user represents in the scenario and where the TE are located in the network fabric. Similar to the abstract, what is the motivation for doing this, and simply having it possible is not enough for the reason. So as a response, we're using MEC to explain when to use this document, and the MEC means the mobile edge computing. For example, in the MEC, the autonomous vehicles could deploy private applications and data on the confidential computing device to calculate the on-vehicle and the destination road information, and without knowing by MEC platform. So I think this is a use case that where the TE users, they don't want the platform or the computer resource to know what I'm doing and what I'm calculating for. So maybe next slide, please. Yeah. This is using NIST standard to specify secure channel, and in this draft we refer to the NIST special publication 800-133 to define the secure channel, and the definition is the path for secure channel is that a path for transferring data between two entities or components that ensure the confidentiality, integrity, and replay protection, as well as mutual authentication between the entities or the components. The secure channel may be provided using cryptographic, physical, or procedural methods, or a combination thereof. So I think this definition is very well, and we could use this definition in the draft. So next slide, please. Yeah, I think this is all the updates in this version of the draft. Is there any questions?
Have you been getting much comments, Pingling?
Not very much comments. It's the comments comes from the, I think it is from IETF117. There's no much comments on 116.
So let me do a quick poll here in the room. Just raise your hands. Has anybody reviewed the latest draft? No. Okay. Has anybody reviewed the original draft? Okay, 3. So the reason why I'm asking, Akita, go ahead. Oh, okay. He was on the queue, disappeared. Okay. So this is all Pingling to ask you if you feel this is mature. Do you want me to do an early review, a working group last call?
Yeah,
Or
I
do you
think
still...
maybe next meeting is possible, I think.
So you want to
Well,
wait one meeting before we do
Yeah.
a working group last call? Okay.
Yes.
And, you know, for all of the TEEP participants, if you can review the latest draft and provide feedback would be good.
Yes.
To
and
assess
welcome
maturity.
people to review this document. Yeah.
All right. So much for having slop. We're tight on schedule. So Pingling, I think you're up next.
Yes, it's another. I think it's an interesting idea. This is a TE distributed provisional relay. And next slide, please. Yeah, this slide is about the architecture of how we test the distributed application, or how we provision the distributed application in the TE cluster. So first, let me introduce the architecture of the distributed application. And in the big data area, or the big data computing framework, like the Spark, Mesos, or Yarn, they always use the distributed architecture to arrange applications and computing resource. And the master node, they run the main part of the application and dispatch tasks into the worker node. And the worker node then runs the task in the executor. And the executor is inside the worker node. They are in charge of running any tasks from the worker progress. So, and another issue is that tasks are the real place that the big data is processed, and the tasks could change dynamically during the process stage of the application. So this is a background of this draft. So next slide, please. Yeah, then there will be a question. So when we use a TE cluster to run big data framework like the Spark, and how to attest this distributed system during runtime? Because you see that the task could change during time, and the executor in worker nodes runs tasks that are distributed by the application.main. This is the first step. Then the task could be updated during the run stage of this application. So the question is that the remote attestation of the distributed framework is a dynamic action. So when you attest this TE cluster, then you get a response or evidence, but you don't know if the evidence is right. You don't know the reference value of the evidence of the TE cluster. So this is maybe a question. So next slide, please. So the resolution is that when you want to attest the TE cluster, first you attest the master node first, and the master runs the application.main, which reference value is stable during the runtime, because its function is to distribute tasks to the work node, and its function and its reference value is stable. Then we using a master as the transfer station to relay task information of workers back to the verifier and the relay party, because the master knows the specific status of the executor, and it could relay all the messages back to the verifier or relay party. And then the verifier or relay party could use this relay information to generate the dynamic reference value of the different stage of the worker node. Then it could do the remote attestation and to check if the T cluster is trustworthiness. So next slide, please. Depending on this hypothesis, we designed three messages. This is the relay message generated by the master. The first one is the task serialized message, and these messages are generated by the application.main in the master, and will be serialized by the relay message, and then be transferred to the relay party or the verifier. And the second message is the worker hardware manifest. It's about the hardware information of the work node, like the TE architecture, memory setting, etc. And the third one is the worker software manifest. It's about the system and software information of the work node and the executor, like the operating system version, system software list, etc. It's similar to the suit manifest, I think. So next slide, please. Yeah, here's the next step of this document, and I think there have three further steps of this idea. First is we could verify the hypothesis of this design to make sure if this distributed application and how to remote attestation it is correct. And the second is specify the relay message context and make it more specific. And the third step is align with the suit and other document like a rights document. And yes, I think that's all of the presentation.
So I guess my question is, has anybody looked at this draft? There's no. I think you just submitted it
Yes.
recently.
It's a
Yeah.
kind of new draft.
I'm not sure that this is in our scope of the charter.
Yes.
But it also looks like you're still trying to do some verification of what you're trying to propose.
Yes.
Is what I'm
First,
sensing.
yeah,
So.
when submit this draft, I think it's could be the tip or could be the rights. So I'm still trying to verify this draft and make sure how to align with the scope or try to convince people and it's suitable for our design and the charter.
Okay.
Yeah, maybe,
so I think when you have, sorry, go ahead.
Yeah, maybe I think this is very interesting issue. So if people are interested in this document, we could talk after the meeting, because I think in the big data area, I think a TE cluster is more useful than the standalone model of the TE device. Yeah.
Okay. I might suggest that you post on the mail list and see if you get interest from others to collaborate with you. And then when you're ready, we can bring it up again. Okay?
Okay. Thank you.
All right. Thanks. All right. I think we're back on track. Juan? Yes. Sorry, I need to find your slides. You want to stand in front of the microphone. We might need to pull it down.
Yeah, that's that. Okay, hello everyone. This is Jen. Yeah.
You need to be closer to the microphone.
Okay. Am I well heard? Okay, good. Hi everyone. This is Jen from Alibaba Group. Today I'm bringing a new document. It's a confidential virtual machine provisioning in cloud environment. So next page, please. Running into the risk of stating the obvious, but everybody knows cloud computing brings benefits together with the concerns. Meanwhile, we're just enjoying the benefits of the easy scalability, flexibility, better security, etc. We also have concerns. One of which is the privilege that comes with the admin of the infrastructure. So, for example, service provider, they manage and control the infrastructure. So the cloud users, they may have concern that the admin may have too much privilege to see everything they created in the cloud. So next page, please. There are many hardware-based security technologies these days. For example, the memory encryption. This is used to protect the confidential and sensitive data in the memory. As we know, there is a code put attack. So this is to defend that. Also, we have heard secure boot, trusted boot, or remote attestation. This is just to ensure that the boot process, the firmware, the BIOS, everything is secure. Also, the trusted execution environment, I think we are not strangers to that. This is a TEP working group. And last, there is the confidential virtual machines. Well, this is to prevent the malicious tampering of the virtual machine created by the cloud users. So if you could just go to the next page. Yep. Here I listed some of the scenarios when a cloud user wants to create and manage the confidential virtual machines in the cloud environment. So you can see in this figure, a cloud user may start with the resource manager by communicating or negotiating the features of this confidential virtual machines they want to create. This is just a rough idea. We're not going to details of how we define the messages and everything, the format details, etc. And after that, the cloud user may want to do a feature discovery or enabling, followed by requesting to create a new confidential virtual machine in the cloud. So this is not a exhaustive figure. We also have like after we create the confidential virtual machine, we need to testify that, we need to verify. We probably want to also retrieve the measurements from the confidential virtual machine, etc. But all this stuff now it is missing. So we're proposing just to create a protocol for all that. So if you could just go to the next slide. Yeah, I took the initiative to draft the standard, and this is the abstract. So basically, we want to specify the confidential virtual machine provisioning in the cloud environment, including the whole provision process, the management of the life cycle of the confidential virtual machine, etc., and probably the message definitions between the cloud user as well as the cloud provider, and also the security requirements, of course. If you could just go to the next slide. Thank you. And here, there are the tentative table of contents in this draft. We have the overview. We have like the feature negotiation, as well as the whole life cycle of the confidential virtual machine, including creation, verifying, reviewing stuff, also including the migrating a live confidential virtual VMs. We're probably going to define all the messages involved in all those scenarios. So that's just a tentative table of contents. Yeah. So this is a pretty very simple introduction of what I want to do in this working group. So I would like very much your comments and invite you just to to work with us.
Ping Ling, you're in the queue.
Hello, can you hear me?
Yes.
Yes.
I watched the document. I think it's not a very complete version. It's a very new version.
Yeah.
It's not finished yet. Is that right?
Right. This is basically, we want to bring up the idea first and get everybody's comments.
Okay, and the message in this draft is belong to TEEP message, or it's a new message?
I think what we're trying to do here is we would like to use as much as possible what we already have now. But if there are new things we need to extend, I don't think we mind doing that.
Okay. Oh, thank you.
Thank you.
Okay, next in the queue is Dave.
So a couple of comments. Let me see if I can remember them. First of all, I think this is squarely within the charter of this working group. Just to compare it to Nancy's comment about the last one, which I agree, the last one is as yet unclear as to whether or not it's within the scope of the working group. I think this one clearly is, because it's about provisioning of TE stuff. I think the use case is super important, and so I am a big fan of having this group do something in this area. Disclaimer, I have not read the document, and so I don't have any opinion on whether the particular details of the document or whatever is good or not, but the topic and the slides and stuff, I would support the working group doing work in this area. I think there's, in the title actually combines two different things, which is actually the dominant use case, is the combination of those two, right? One is provisioning of confidential VMs, right? And we don't have any other document that talks about provisioning of confidential VMs. And the other one is provisioning in a cloud environment, okay? Which we don't have. It's a different use case than, say, the transport spec that we have for the TEEP protocol right now. We have had documents that say, and this was the presentation that I gave on behalf of Mike Purcell, whose trip got canceled at the last minute, where the TEEP protocol could be used in that. But not with the transport that we have right now. You need an alternate transport that we've never specified, right?
Right.
And so this gets to a question here. Given that I haven't read the document, I was going to ask you, because I can imagine multiple ways you can do it here.
Do you have a document?
Well, you got a table of contents, so presumably there's
Well,
a table of contents.
actually, I do
Maybe
have
it's in your
a
head. So.
yeah. I'm sorry, I do have a
Okay.
draft
Okay.
standard which I sent out earlier to
Okay.
the chair. I think yeah.
All right.
I
So,
don't remember.
Anyway,
You have to submit it. Oh,
Okay,
did you?
it
Yeah.
doesn't
Okay.
matter because I can talk about hypothetical documents and
Sure.
whether it matches or not, because I can imagine there might be more than one.
Let's
so.
do that. Let's do that.
But so
Because if it's not written yet, you can always write it the way that I would want it. So I don't know. So one is whether the agent that is being provisioned, not the CVM that's being provisioned, but there's something got to talk to at the other end, right? Like in the TEEP case, you got a TEEP agent. You're not
Mhm.
provisioning the TEEP agent. You're provisioning, a trusted app that's in there. Okay. Whether the agent is running inside or outside of the TEE. If the agent is running outside the TEE, then in previous discussions that's not written any place other than emails, you'd say, can't I just use Kubernetes in a cloud environment, right? I can provision stuff with Kubernetes, and it happens to be launching something that might be running inside there, but your provisioning protocol you don't need TEEP for that, right? This came up in the working group when we added the applicability statement into the TEEP architecture document. And there's a paragraph or a section of the TEEP architecture document that says you don't need the TEEP protocol to do that because there's existing protocols. Just use an existing one. TEEP protocol is only applicable if you're doing something that runs inside of a TEE, right? And you don't have some other protocol that you can do. So one way that you could do a document is you could say how to use, informational document, how, maybe it's normative, I don't know, how to use, Kubernetes to deploy CVMs, right? That would be one style of document, okay? Where you're doing everything you're doing all the attestation at load time, not at deploy time. Now, of course, you could do some deploy time stuff too. If you're saying capability detection, I only want to deploy it to a machine that has, CVM capabilities like you mentioned. So that part's good. The other way that you could do stuff is you could say, maybe there's an agent that's running inside of a TEE in like a nested VM case or something like that. I'm guessing that's probably not what you're doing, but that might be a case where you use the TEEP protocol to do it and you need a different transport. Okay. So depending on what you, like Alibaba is interested in doing, there might be multiple opportunities to collaborate here, but the bottom line is I think the working group should do something in this area.
okay.
Can
So
I just quickly respond to what Dave just wrote?
okay, let me respond as the chair.
Yeah,
I think
sure.
we need to revisit the charter because the charter speaks about the trusted. So if you're expressing interest, then we need to talk about rechartering, right? Or extending the charter. Right. So go ahead, you can respond.
Yeah, just a quick response would be, I don't think we need to limit ourselves to either way. We can talk both. We can explore both. That would be much more interesting, I think.
Hi, this is Hannes. I think this presentation very nicely lines up with the use case presentation of Bengling earlier, not the one in the middle.
No, the one before, the use case.
Because it talked about sort of description of the different models that Dave just alluded to.
Right.
And I think there's, and I even think that this is in the scope of the charter to talk about the provisioning of in those environments, as we had talked about before in some of the confidential computing use cases. So I think it would be quite interesting to see how we could use the TEEP protocol for that specific purpose, most likely with a different transport though. But many of the other pieces should actually work. And that was my impression when we had these discussions in context of Bengling's presentation. But I think we need to really evaluate where things fit well and where they don't fit well.
Right.
I think we have to dig into the details. There are a lot of details, unfortunately, and there's a lot of
which is why I'm
work in the
putting in
confidential
question,
computing,
right? Because depending on the
consortiums.
details, I don't want to grow the scope because our charter is very tight to using a TEE.
Right.
So
But I
it's
think
fine if the
that's good,
working group
yeah.
wants to, right? It's up to the working group as to whether you want to adopt this, but I think there's not enough here for me as the chair, right, to ascertain the paths forward. We adopted the use case because it clearly maps a use case for the TEEs. I just wanted to make that clear. Sorry, I'm running everything live. So are you on the queue?
It's okay.
Not yet, but we'll go ahead, Ming.
Ming Pai.
Yeah, well, that's yeah. I cleared the queue. Go ahead, Ming, and then Dave will be on the queue.
Ming Pai. I think this is a very interesting use case. But I think this charter initially just really for trusted application, and then focus towards application. This one go to from application to a machine, right? To a with a node machine, whatever in a
Right.
Kubernetes or other cloud environment. It's a very different scope. Yeah, I agree that at least we may need a revised charter or other aspect. But the use case itself is interesting. We have been talking in the past.
Yep. Go ahead, Dave. Thanks, Ming.
You made half of the comment that I was going to make, right? Because the chart, so I went to the charter, right, was you were talking there.
Yep.
And it talks about specific documents. And you can read the charter as saying, well, it doesn't actually say that the use case document in there. It says, well, we just said that that kind of falls under the overall, architecture document. We can split one thing into two or whatever because it's a use case.
Right.
So I can imagine you could do the same thing that says, as long as you're just describing the use case and it's just informational, you could adopt a document right out without rechartering. Because if you don't think you could have, you couldn't have done the use case document either, right? So whatever the justification is, if it's in the same category, maybe there's even a way to put it in the same document. I don't know. But different hat. So that's one point. The other point, maybe with a confidential computing consortium hat on, I'm no longer the chair, but I'm still on the TAC. The use case in this document, my opinion is this use case is actually more important than the use case for the TEEP protocol. Right.
Well, so I was actually
CVMs in
going
the
to,
cloud is where the trend is, right? So this is the one that's on the uptrend. The other ones are on a relative either downtrend or stable. This is where the biggest interest and growth is in this particular area.
so
And
I'm,
so if we
I'm
need
not
even an
denying-
informational
right.
document, it'll have more impact than the rest of the stuff the working group's doing.
so my question, don't leave yet. Because I was actually going to ask you as a member of the confidential computing, whether this would be a work that should be done there versus here or some hybrid.
That's a fair question. The Confidential Computing Consortium is not a standards organization. It is an open source organization and a marketing organization. And so if there is a just pure informational document, like it could do the equivalent of what we did in the architecture document, that it could do, because it's not proposed standard or anything.
Right.
So the real question is, do we think there's anything in here that would ever be proposed standard? If the answer is yes, then this is the working group to do it.
Okay, so without having the draft, and I need to go back, I apologize if you
No problem.
provided a draft. Usually, and I can show you how you submit it to the data tracker.
sure, I'll do that.
So I think it's a little early for us to tell until we understand the scope of what you're trying to propose.
Okay.
Right. But I think you've heard that there's some interest to the use case. It's just a question of the scoping
Right.
and what you're trying to propose.
Right. So just another thing, or should I?
Yeah, Hank was on the queue, so.
Okay.
Yeah, I'm just stepping forward. This is Hank. I just want to echo Dave's interest, and I also do not think that the current charter is a blocker. It might just be a cut this in two thing or something like that. But that maybe we'll read it and we will comment on it. And I think, yeah, this is a good place here.
Okay. Well, thank you. What I want to say is what we are doing here, the TPP protocol stuff, as well as what I'm proposing, the confidential virtual machine, they actually belong to a broader area of all confidential computing, right? Just why not merge them together? Just in this work.
Well, and
we have all the experts
Right.
here. I'm supposing that
So-
they have abundant experience in this area.
so I think you've heard from folks that they are very interested in the use case. What we cannot ascertain, and that's where Hank and Dave are saying it could be just a question of how we split the beast to,
Yeah.
okay, not the beast.
Yes.
What we're proposing, right? Don't say beast on the minutes.
Right. Well,
Yeah, I'm back up since you didn't cut the queue yet. So
Yeah, go ahead.
yeah, so I'm just going to elaborate more on why I think that this is super important. Right, when we first created the TEEP working group, it was a long time ago, right? And we had maybe more use cases than we have now, right? Because the original use case was for some of the things that people now use, whatever OTRP is called in global platform, which originally they weren't going to do it. And so some of the use cases have kind of moved on because they've adopted a solution that was done by Global Platform now. And so the applicability statement says, if you're doing that, you just use the standards protocol that's already out there like 2 years ago or whatever, right? And so we trimmed down our use cases, right? And then David Wheeler led a great presentation on, is this applicable to SGX, right? And under what circumstances is it applicable to SGX? And we said for a lot of cases, because you're doing the verification at load time, not at deployment time, the answer is it's not, right? So we trimmed that part out and says, okay, you're only doing this if you're trying to do verification at deployment time. And so we kept trimming down the use cases. And so the fact that we have a relatively small working group, or at least, let me rephrase it this way, out of the things that people participate in the confidential computing consortium and the area of things that are within TEEs or whatever, this working group was covering in the TEEP protocol a relatively small amount of that space once we've done the applicability statement. Why? Because everybody's moved out of this space over into the CVM space. All the big interest and future deployment and discussion and stuff is, why would I use the TEEP protocol if I can use a CVM and just use Kubernetes, right? That's where a lot of the mind share is at, but nobody's written down any place. Can you actually use Kubernetes, and what are the security properties when you're doing TE provisioning, right? And so if, Azure and Alibaba and the other companies doing that got together and wrote something in this working group, that's where actually the mind share is right now. Right?
I might, dang. Okay, I'm the only chair. Never mind. So I think your points are valid, but again, we need to just revisit, right? And so I just wanted to echo Daniel McGault on the chat said he's also interested. So I think I'm hearing that there's interest. It's a question of how we scope things and move forward, right? Go ahead, Ming.
Oh,
You need to put yourself on the queue, but go ahead. You're already up. Yeah.
Make up all my missed issues. Yeah. So I just on that comment, I think we have two use cases, right? When we TEEP started, we have the device, really mobile device, many.
Well, and to get chartered too, we had to really
charter
scope.
for that.
Right.
So then we realized that server side, the cloud
Right.
environment, that way, as I think David has more interest, and then we start expand. Right? That way
Right.
we found, there's a lot of confidential provision to the cloud environment. But the initial focus is really more the field devices. So still, right, that's all TEEP product tailored for that. It's a major target because the product optimized for that. So now for cloud, actually very different, right? But I think it's a very interesting. I'm interested in that. Just for the chart, look at the chart description is really tailored for that. So I think.
It was Microsoft's.
That's okay. You raised your hand. I'll recognize you. Go ahead, Dave.
Really start talking about the cloud scenarios other than, oh yeah, and that too or whatever, until it was Microsoft's presentation. That was talking about my use case is NRX to provision the cloud, and the TAM or whatever is on premise, and I'm pushing stuff to the cloud. And that was really the first presentation that I remember. There was an actual presentation in the working group that talked about a cloud deployment. Okay. And so he's right. And so we've kind of scoped down the TEEP protocol scenarios to be the case where it's primarily edge stuff. You can use it in the cloud if you're doing like a microcell stuff that you're trying to, which is the NRX scenario, you're trying to push say an SGX enclave, for example, into the cloud, but only if you verify that you trust the cloud, right? Then that's the NRX scenario. And so it's still applicable there, but CVMs have kind of, and so that's why I said there's two things being put together in the title. One is the notion of cloud, and the other one is the notion of CVM. And I'm saying the mind share has moved away from sort of the enclave notion, which is still in use. There's still valid uses for that, right? Over to the CVM case, which is you just take an existing virtual machine that you've already got, and I want to run it inside of a confidential. It's not a different composition, right? It's deployment time. I only want to put this in there, and it's an unmodified, and it's the interest in lift and shift rather than re-architecting and splitting my application. It's a lot more easy to use, and so it has a bigger in market share interest and people interested in doing that. But it's less secure in the sense that your trusted computing base becomes huge. It's the entire VM, right? Rather than just your little trusted application. And so it's less secure in that sense because you got a lot more surface area, right? But it's a much easier stepping stone to go to a CVM and just take a VM and say, run this inside of a confidential VM environment. And so that's why I said most of the mind share is there, because the masses can do it instead of just the security experts.
You that good.
Yeah, so Ned Smith, Intel. So I want to kind of echo what Dave was saying. but also bring it back to the charter discussion. Like the charters gives some examples of what a TEE is based on existing technology, but technology has moved on. So I think you could have titled this provision of a TEE in a cloud environment, and would have, I think it would be less controversial in terms of charter. And so then the question becomes, is there a crisp definition of a TEE versus a CVM? Right, and I don't know that this is like new technology.
I'm not
right?
that literal, Ned.
Yeah.
I mean, but a lot of it, again, I'll just come back to. Yeah.
I was just,
I had closed the queue because we're out of time, so make it quick.
Yeah. I'm not even in the queue.
Well, I had closed the queue. That's why I'm telling you.
How do you want to proceed with this work? Like, what are the next steps?
So, which is why I tried to close the queue. So if you have a draft, I'll show you how to submit it. So I'm going to have John submit the draft. For all of you who expressed interest, let's take it to the mail list. All of you should be providing feedback as to your recommendations for how we should move forward. And Tito and I will take that under advisement. And we'll move on from there. I won't put dates, but I mean, there's enough interest from the length of the discussion that there's interest by the group to do something there. It's a question of how we scope things, and I don't mind rechartering. If we can keep it in scope, we can keep it in scope. But as somebody pointed out, right, we chartered what, 4 years ago? And things have evolved and changed. So, yeah. Okay, so with that, we are out of time. I thank everyone for your participation. I'll coordinate with Dave with the SUIT co-chairs for closing loop on the protocol, and we'll move forward. Thanks, everyone. And thank you to the Peters for the note-taking.
Yeah, we were thinking about the second week of September. Probably put together a meeting.
Yeah, I'm going to be out of pocket. It's like pandemic over, Nancy's on the road every week. Like anyway, my vacation still hasn't happened because of work. But nonetheless, either Tito and I don't think both of us need to be present. But it's really just like the protocol is stable, right? It's just a matter of getting the blessing and the validation on the suit. And then we'll narrow it down. Yeah. Okay. Yeah. Good to see you, Ming. I didn't realize you were here. How's life? It's all right. I mean, I even saw her nose. The IEB. Oh. He was like 2 rows.